Okay, so this is a different type of drug dosage calculation. In this problem, we are not going to be giving a dose based on the weight of the patient, although you'll see in the problem that the patient weight is given, right? It says Jalopy is an 88-pound dog about to undergo treatments of chemotherapy at a dose rate of 5 milligrams per square meter of body size. How many milligrams did Jalopy receive in a single dose? So this phrase here, a dose rate of 5 milligrams per square meter of body size, is an indication that we are working with what is known as a body surface area problem. So BSA, which stands for body surface area, is a unit of measurement because it is an area that is a squared unit of measurement. So in this case, it's square meters. So if I were to write down the information, the weight of the patient is 88 pounds, and the dose is 5 milligrams per square meter. So when you see the dose given as a rate per square meter, that's an indication of a body surface area formula. So what we really need to do is just change the 88 pounds into some number of square meters. And we're going to do that using the body surface area formula. So for canines, there is a different formula for each species. The body surface area is calculated using the following formula. So the W, the one variable in this case, is the weight of the animal or person, whatever it happens to be, but in kilograms. So we are going to need to take the 88 pounds and change it into kilograms. And then we just follow the order of operations in the formula itself. So we'll change the weight of the problem, the weight of the patient into kilograms. That's what our W will be. Then we're going to multiply by the 1,000. Then we're going to raise it to the 0.67 power. Then we're going to multiply by the 10.1. And this 10.1 is specific to canines. You'll notice there's a separate value in there if you're dealing with a cat. And then last but not least, we're going to divide the result by 10,000. So on the next page here, I'll write all of that out. So the BSA steps. So 1, change the weight to kilograms, if needed. Right? If we already give you the weight in kilograms, you don't have to do anything. But that's our W in the formula. That's what the W is. So multiply W by 1,000. Raise this to the 0.67 power. So you're going to need to use an exponentiation key. So one of the following keys is going to end up being on your calculator somewhere. So you may have a key like this, which has a little caret symbol, which means exponentiation. Or you may have a key that actually looks like an exponential expression, but you're going to use that. And then we're going to multiply by 10.1. And like I said before, this is canine specific. If you were doing a cat, this step would have a different factor in it. And then last but not least, divide by 10,000, and then round to 2 decimal places. And my handwriting's getting a little sloppy. Round to 2 decimal places. And then that should do it. So again, change the weight into kilograms, multiply those kilograms by 1,000, raise that product to the 0.67 power, multiplied by a factor of 10.1, which, like I said a couple times now, that is specific to dogs. It's a different formula for a different species. And then when you're done there, divide by 10,000. So let's take the 88-pound weight and go ahead and put it through these steps. So we know the dog weighs 88 pounds. And we know that 1 kilogram is 2.2 pounds. So that's going to cancel. And when I do 88 divided by 2.2, I get exactly 40 kilograms. If it doesn't come out to be exact, you can round to a couple of decimal places. So the body surface area calculation is going to look as follows. If I set the whole thing up, and I will try to make this as neat as I can. So these are my steps. So I'm going to take the number 40, multiply it by 1,000, raise that product to the 0.67 power, then multiply by 10.1. So just keep in mind, this part here is all done first. So after you multiply by 1,000, raise it to the 0.67 power, then multiply by 10.1, then divide by 10,000 at the end. So when I put all of that through the ringer here, just hold for a moment while I'm done. I come up with 1.22377, et cetera, meters squared, which we will just round to 1.22 meters squared. So that's the body surface area. So practice with that formula and make sure you get the same answer that I did. So now to find the final dose is very simple. We're going to take our 1.22 meters squared and multiply by the dose ratio given. We were told to give this drug at a rate of 5 milligrams per meter squared. So if you have to go back to the previous screen, actually one more screen, that's the information that I have underlined in yellow, 5 milligrams per square meter. So when I do that, my meters squared cancel, and I want 1.22 times 5, which comes out to be, 6.1 milligrams. And that ends up being the final answer.